All right, so here's the deal. Basically, I want you guys to have time to work, have time today to work on these problems. At the end of the video, I said, hey, here's the problem. Try it on your own. A lot of people came in first hour and they're like, I have no idea how to do that. So, let me show you how to do it, and then you'll have the rest of the time to work. Okay? So, before we go over it, a couple quick general things. Thing one, please make sure that you are aware of the difference between, for example, north of west and west of north. Okay? For all of the problems, I gave the answer, right? I will usually give the answer so that the angle is described as north of or south of something. All right? But there's nothing magic behind that. So if you just decide to describe it as east of or west of, that totally works. All right? Now, if you don't know what I'm talking about, here's what I'm talking about. Suppose we had an arbitrary vector that pointed, say, this way. Okay? And I calculated this angle, and I discovered that this angle here was 30 degrees. All right? Then on my answer key, I would write, however far at 30 degrees north of east. But Ray, meanwhile, is like, I don't want to do it that way. I'm instead going to find this angle. That's cool. But the difference is, instead of writing 30 degrees north of east, Ray is going to write 60 degrees east of north. Is that wrong? No, it's just a different way of describing the same direction. Make sense? So if your angle does not match my angle, check and see if that's the issue. Maybe you have just described it in different terms than I did. Good? All right, that's common issue number one. Common issues 2 and 3 and 4 I'll talk about later. So, in the video, I did this problem where Roy walked 3 miles this way, then 4 miles that way, and he had to find his overall displacement, right? Okay, and I showed you guys this method where you find your vector components, you make a chart, you find the result. 3 steps, right? And then I said, okay, now you try it. Here's this ladybug problem, right? So what I want you guys to understand is it's literally the exact same process. All right, the only difference is your units. We're no longer talking about miles, now we're talking about meters per second. But you solve the problem the same way. Good? All right, so yesterday I made the comment about the ant crossing the conveyor belt problem. I knew I had done it, but it's here, not in video 2.1. So here's the deal with, let me just kind of explain conceptually what's going on here. All right, so suppose you've got a ladybug. Why did I just throw that? I don't know. All right, here's our ladybug. I'm unhappy with this, but we're going to stick with it.
It's down there. Oh my god, it's weird.
What? I'm going to make him better.
Oh yeah. That's yeah.
Marginally better.
You're marginally better. All right. Okay. So there's our ladybug. All right. So let's suppose hypothetically that the ladybug is hanging out and he sees a can of beans over here. And you guys might not know this about ladybugs, but they love some beans. So the ladybug begins crawling this way. Okay, at some speed. Tink, 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 tink. That's the sound a ladybug makes when he walks. Tink, 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 towards the beans, right? Tink, 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 tink. Okay? Good? All right. So right now my ladybug is going that way, right? But where do they have beans? At the grocery store. Where do you put the beans? On the conveyor belt. So you pay for them, right? So the lady at the grocery store is like, well, I got to ring up the beans. So she charges on, turns on the conveyor belt, and the conveyor belt starts moving this way. So the beans are going to go this way. The ladybug is going to go this way towards the beans, but as the conveyor belt carries the ladybug, what's it going to do? Which way is the ladybug going to go? This way, right? Right? Because the conveyor belt's going while the ladybug is going tink, 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 right? So you're going to get tink-a-tink, 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 right? And so here's the velocity of the bug, here's the velocity of the belt, here's the overall velocity, right? Make sense? On your homework, there's a problem about a boat crossing a river. Same thing. The boat's going this way, the river's going that way, the boat goes... Cool? All right, so the problem is, on the problem on the homework, A, not on homework, the problem that we're about to do on the notes, A, this isn't a right angle, okay? And B, the whole thing is at a weird, funky angle, so it looks like this or something. Okay? Good? All right, great. So does everybody understand that the bug's motion is going to be affected by the walking and the belt? Okay? And so what we want to do is add those two vectors. So how do we do it? Here is how we do it. So let's big in this. Here we go. All right, so the ladybug is crawling at 0.36 meters a second at 60 degrees north of west across the belt. But then the belt turns on, and the belt moves at its own velocity. So we got to find the overall velocity of the belt, or of the bug, anyway. All right, so first of all, let's give the two vectors in the problem a name. All right, so the ladybug is doing this. So let's call that vector L for ladybug. You can call it whatever you want. You can call it A, you can call it B, you can call it Q, you can call it ladybug. I don't care. Give it a name. I've chosen the name L. Here we go. So vector L is 0.36 meters a second at 60 degrees north of west. Okay? The cashier turns on the conveyor belt, which moves at that speed at that angle. So let's give that vector a name. How about vector B, as in belt? So that is, bless you, 0.24 meters per second at 50 degrees west of south. Who wrote this problem? All right, so here's what we're going to do. We're going to draw a triangle for vector L and find the x and y components. Then we're going to draw a separate triangle for vector B and find the x and y components. And then we'll do some other stuff. But let's do those two things first. So are there questions before I start? Okay, so vector L. We're going northwest. So here's north, here's west, here's northwest. Good? So that's my vector L. Now, one of these two angles is 60 degrees. Is it the top one or the bottom one?
Yes.
North of west. So that would mean start at west and then go north of it. 60 degrees. There it is, bottom one. Make sense? Any questions? Joey, you good? What's up?
Yeah, no, we're good.
You sure?
Yeah.
All right, so there's our vector L, 0.36 meters a second. So now, draw your triangle. Make sure it includes the given angle. All right, put arrowheads on it. My horizontal component, is it going to point left or right? This bottom guy points left or right, you guys? What do you think? I got one vote for left. What direction is the vector pointing? Left or right? Left. So which way does the component point? Left. All right, how about the up and down component? Up, right? Good? Now, some of you are thinking, because I apparently overstressed something incorrectly. I kept saying yesterday, make sure your vectors are head to tail. Make sure your vectors are head to tail. But these are not, right? That's head to head, and this is tail to tail. All right? When I said that, what I was trying to, and apparently did a rotten job explaining, it's your components, the x and y components that have to be head to tail. All right? So where the right angle is will always be head to tail, and the other points will be head to head and tail to tail. Make sense? All right, cool. So if this is vector L, what should I call this guy? Lx, and this guy should be Ly. Does anybody have questions on that? Okay, do I need to go through the trig? Sine and cosine, right? Okay, so this one turns out to be 0.18 if you do the trig, and this one turns out to be 0.312, I believe. All right, am I done? No, what did I forget? Negatives. Negatives. Should either of these be negative? Lx points to the left. That's negative. Ly points up. That's positive. This is a sideways equal sign, if you're wondering. Ly equals positive points. Sorry, I didn't give myself enough room. Alex, yes, sir.
If you always like draw to like, you know, if you've been like doing the in math class, you always been drawing it down to the x axis. You don't really need the arrows, right? I mean, they don't really do anything.
You need the arrows.
Why?
Because when we get to forces, it'll make your life easier. It's a thing. Okay. I promise it'll make your life easier later on. So bear with me on it. Okay, everybody good with this? All right, so let's put that information in our drawing over here. So we just found the x and y components of vector L. So the x component is negative 0.18. The y component is positive 0.312. Cool? All right, now do the same thing with vector b. So let's see, we're going west and south. So here's west, here's, oh, I didn't want to put an arrowhead on that. There's west, there's south, here's southwest. That's an arrowhead. So which angle is the 50 degrees, top or bottom? Bottom, right? Because we want west of south. So here's south, here's west of south. So there's our 50 degrees. This guy is 0.24. Complete your triangle. So if this is vector B for belt, then this guy is B Y. Should it point up or down? Down. Here's our BX. Should it point left or right? Left. Cool. That is the worst triangle I've drawn all day. All right. Everybody good? All right. And then do the trick, right? So if you do this, you get some numbers that I don't remember. This one's negative 0.184, and the other one is 0.154. Doing that from memory. This one should be negative style. All right. Is everybody okay with that? Problems, questions, concerns, anything? Okay. And everybody's good with why I've got the signs the way I do? Okay. Alex, I'm sorry I didn't give you a better answer. Let me think about, see if I can give you a better explanation than just because you need to. That would bum me out if I was you. Screw you, Mr. Hecker. All right. All right. So here's the deal. So let's think about what these mean. All right. This number here means that because the ladybug has legs, he is walking to the left 0.18 meters every second. Right? This number means because the conveyor belt is on, the ladybug is being carried to the left 0.184 meters every second. So the combined effect of the ladybug's legs plus the motion of the belt gives a resultant x motion of negative 0.364. I just added those, right? The legs are carrying him to the left 0.18 meters. The belt is carrying him an additional 0.184 meters for a total of 0.364 meters. Every second, he's going to go that way, that far. Cool? So everything here is meters per second. That means every number on this chart is meters per second. Except for the angles, obviously. Cool? All right. Now, what is this telling me? Well, this is telling me that the ant is trying to walk north 0.312 meters every second. But as he's walking north, the belt is carrying him south at 0.154 meters a second. It's like walking the wrong way on one of those moving conveyor belts at the mall or the airport. Know what I mean? Okay? So who's going to win? Well, the positive number is bigger, so he's going to go north, but just not as fast as he would have otherwise, right? So if you figure this out, it gives you negative 0.158, I think. Oh, but it's positive, sorry. Cool? So this is my x component of my resultant. This is my y component of my resultant. Follow you guys? All right, so now we've got a vector, we know the components. Now we just draw the components and put the vector back together again. Cool? All right, so let's see. I always draw the x component first, so here it is. Rx equals negative 0.364, left because it's negative. Where do I draw my ry, you guys? Over here? No, head to tail, right? Over here. Cool? And then, here's your vector r. Cool? So, how do we find r? Pythagorean theorem. So, oops. So, r ends up being, if you do the Pythagorean theorem, we get like 0.40. What are the units going to be? Meters per second at, let's say I need to find this angle. So use inverse, sine, cosine, or tangent. I always use tangent because I do. And it gives you about 23 degrees or something like that. 23 degrees, what of what? North of west. Good? Problems? Issues, concerns, anything? Hooray! Now, is this the only correct answer? No, because Drew did this. I don't know if he did or not, but maybe. And he got 67 degrees west of north. So minus 1,000 points, right? No, because these two things measure the same thing. That just means that Drew, his triangle. I'm glad one person thought that was funny. His angle that way. Good? I said Drew. Okay, questions? All right, you've got some amount of time, half an hour or so. During that time, you should be working on worksheet 2.2. I'm going to be circulating around and looking at your triangles to make sure that you got arrowheads. Good? That's it.